Good evening, folks. Today, my topic is managing digital twins. So this is basically a past service which I'm going to cover. Unlike my fellow colleagues who have covered the code part of it, just to give a I have not given my introduction here. So just to give an introduction, I work for ABB as a DevOps engineer, and I'm into this industry. I started my career as an operations guy, and now into DevOps as well, and I lead co-managing our operations team under robotics department. So this particular topic was kind of interest to me because currently I'm working for a robotics division inside ABB. So robotics, as you see, it's an IoT offering of any cloud or any technology. IoT itself is a technology which is driving the Industrial 4.0 solution. Industry 4.0, the machineries, the turbines which are running, and the challenges which we were facing why this particular digital twin comes, because many of us, as I've just heard, many of us still don't know about this topic. So I will go with a brief introduction for that. I plan to do an advanced one for this probably next time. But yeah, I just want to get equipped with what exactly it is, so that I can cover advanced sessions on this in the forthcoming sessions. So about digital twins. So this is what was why this digital twin came into existence. So when it comes to this, last 2 years, how was it like? When industries and all those factories were close enough, and people and the survey engineers were not able to go to the turbines or to see the robotics, to see actual power in the pipeline. So this is when last 2 years it has evolved. The general availability for digital twin to Azure came into the picture in December 2020. So this is why this comes with the, you might have heard the terms like digital transformation, and with the last 2 years with the COVID times, when we were not able to go to the our offices. So that's what this technology evolved more and more. Last 2 years, this particular technology, digital twin, was since decade. This was used by NASA first in 2010, and then slowly the other cloud vendors like AWS started with their own digital twin technology, which was developed in 2016. Then 2020 December, Azure comes up with the digital twin solution of the industrial offering. So what exactly it is like? When the service engineers were unable to go to the industries to troubleshoot the issue with the turbines, motors, or what is the issue with the high level in machineries, then this technology evolved up. So digital twins, as I was also I have just created service also in Azure. It's a virtual representation of the physical assets. Like while sitting here, you can troubleshoot, the service engineer can troubleshoot a machinery issue or robotics, any fault in the machinery virtually. He can just install the digital twin components, and Iot Hub will be installed in the factory. That will give the spatial representation what's exactly how the turbine is working or how the robots are evolving in the industry. So it will virtually represent the components of it, like in front of the engineer who is troubleshooting the things. Because this technology, as I said, it was not possible to go to the factories in the times of COVID and all. So this is where this evolved from digital transformation. Then it comes the digital twin. So we can virtually see the things which are any fault in the machinery. We can troubleshoot with the help of this technology, which is digital twins. I'm just going to the next slide. It's not. Sorry. So yeah, this is the pretty much agenda which I want to cover, like digital twins and the use cases in the manufacturing sector. And not only in manufacturing, this is used in real estate also. Like the countries like UK are developing the real estate with the help of this digital twin solution. Like how to This is not not even in manufacturing, in the carbon CO2 emission, the environmental hazards which are happening right now, which is the climate change. This is UK and especially Sweden and UK are contributing heavily using this technology to reduce the CO2 emissions. So it is also helping in the environmental, contributing reducing the CO2 emissions, which will help in the climate change going forward. And we will see some of the use cases in Industry 4.0, which we are living right now. It's Industry 4.0, which is the driving factor of Industry 4.0 is all the digital technologies which we are seeing right now, the robotics, and not only in the manufacturing industries and the real estate, now it is also used in the health sectors. So for example, I will give you an example. So you are aware of, I think, metaverse. So metaverse is built on top of the fundamental concepts of digital twins. So while digital twin represents the virtual representation of a machinery or any product, whereas the metaverse represents a human representation. Like virtually, if I am not standing here, I am delivering the sessions. Metaverse you might have seen. So those metaverse is used in the healthcare industry. When during the COVID times, what has happened is doctors were not able to see in person the patients. So they were using, still it is being used, before the COVID also it was used, metaverse was used. So metaverse is developed on top of digital twins. So the fundamental concepts is still the digital twins, and then came the metaverse and what you are seeing right now. So in this what you call the digital event, which is driving with the Microsoft, which is I think just concluded. I think drive by it's happening one yearly. So they are Microsoft is heavily investing on metaverse and its use cases. And also the digital twins concepts. It's still developing. Azure is still growing. I would say it's not mature enough if it's come to the implementation, but it's still meeting up to the standards of what AWS has done as a cloud. So it's still growing, and it's evolving technology. And I will walk through the models, like how we will create the models, actual sample models, because this is just a sample demonstration which I don't want to make things complicated, because models are complex to understand. But we'll see, like it's a JSON files, like how to design the modules. We'll cover that, like how to do that, and the properties which are there. And then the simple demonstration using the Azure portal, and then some of the technical briefing, what it needs to drive this for the. So I think I won't just 5-7 minutes more into the theoretical part, then it will directly jump into the portal. So I think this is already covered. Why digital twins? This came because when we were not going to the industries and trying to troubleshoot on the actual problem with the machinery. So this is so why digital twin came into the picture is it helps in the you might have heard this word predictive maintenance. So this has evolved from the term called data sciences have used this term. So digital twins is using a lot of data. So, industries and this machineries, robotics industries, terabytes or petabytes of data. So to manage those data, right, we need some technology like and the maintenance, how the machinery will behave perform in next quite 1 quarter. So this is done using predictive maintenance. So digital twins is responsible for doing a predictive maintenance of all the things using the IoT device. So I just want to give context. So digital twin came into the picture. See, IoT was already there. IoT is since more than more than a decade now. IoT is first come to the picture. The challenge with the IoT was data was huge, and IoT was it's all about the sensing the objects and sensing the objects, and then the data which is related to the machineries from the anything. Then it used to analytics was the problem actually. It was not able to when you have seen the Power BI, right, the representation, that representation was missing. Then it came into the picture the digital twins. So when we IoT came, then to visualize those things, the data, which is huge amount of data which is generated from the machinery. Then it came, after IoT, it came the digital twins to have this in a good representation format, like to analyze the spatial data in a virtual context. So then it evolved, like things got started evolving, and then came now the metaverse. So IoT was pretty much, but it was not enough to help the scientists or the engineers to get the actual data, predictive maintenance, like predicting the events or how the robots or the machines will behave. So this then it came, this concept evolved, and just see. Just go forward, and then I think this is just about how it evolved. As I said, 2010 NASA was the one to use this technology first, and then Azure, May 2020 it came. They were doing the experimentation, and then December 2020 it was came out as a general availability. And this is I'm explaining in the context of Azure, but this is because here in ABB we are using Ability Cloud. You might have heard Ability Cloud. This is built on top of Azure. So my focus would be on Azure, I think, and this one, but AWS has a separate offering for digital twins. So still Google is developing the solutions on Google Cloud on the IoT spaces. But I think if you see how AWS and Azure have evolved using this in the digital twin, it's commendable. And so these are the two leading clouds which are as of now still growing and evolving the solution in the digital twin space. And then at that I was saying, like digital twin, IoT in the metaverse, this is like this has been evolving things which are coming, which I've just said. So these are the smart cities. This is the example of the UK, how they are developing the real estate using the sensors and connected devices. So it's all about the connected data. That we have the edge solution. Edge computing is there. So edge computing, and there are devices which are connected. And this is the edge computing is driving the IoT revolution, and where the thousands of devices are connected using connected service solution and sensors, which is and then comes the challenge which we had to address in terms of visualizing those things using some kind of technology which we will learn, like how to get started with digital twins. And then quickly. So I think this is I've covered, like how, but this is some of the examples how Volkswagen, Siemens have also been using this technology to project growth on the best example which I've seen in YouTube is the IBM is the first one to use digital twin effectively. When I see this. This is that video is there since last 6-7 years now, that they have started using, when even Azure was not even into the picture of having this solution when it came in 2018. So the guys like IBM and Siemens, especially IBM, have been using their own customized digital twin solution. IBM also has separate cloud that is separate from the Azure and AWS offering. So they were previously using. And the turbines example which I have been giving, this is I saw in one of the Siemens, where how their engineers were troubleshooting the real time. For example, the turbines are there, oil leakage issues are there in the machineries. So how they were troubleshooting these with the help of digital twins. This is all they started using couple of years back in the Siemens use cases. So I think this is some of data which I've just collected, and I think. And I think after this I will just go through the surveys, how it's been created and how the models have been designed. So it's just a JSON-like language which digital twin is using, which is again, it's not a YAML one, it's a JSON one. So but this is called JSON LD, which is called digital twin definition language, DTDL. This is the extension which has been used, custom extension, like to define the digital twin models. we will see how we will create the models using this language, which is DTDL. Now, to go ahead with, we will be using for advanced use cases. I will be using Visual Studio Code with DTDL extension to publish the to design the models. Publishing model in the events I won't be able to cover in this session, but yeah, I'm planning to cover that one as well in forthcoming months. And then we will have the Node.js, and then we have the latest NPM version installed, and then the Chocolatey for the package manager. I didn't do these things with the Azure DevOps pipelines, but I think that's my next focus to drive this even in my organization to develop a pipeline for designing this solution, the digital twin solution using the build pipeline for Azure for this thing. But yeah, so this is like pretty much now I'm planning to move to the Azure portal to show the I think elements I will cover once I go to the portal and show you the how it has been done. So this is let me go to the portal first. Yeah, so this is the one of the service. If you go to the portal and create a resource, this is like Azure Digital Twins is the service name. And this is a PaaS offering of Azure, where it's used like if you can see the description of this service, what it does, and this is we'll see this one like the virtual representation this model I will show that how I have designed it, and but it's just a simple one, this which I have just shown. So this is the service which I just wanted to show. This I've done with you my own subscription. So so this is like, it doesn't cost anything. I will show the cost. So cost, if you see, trillions of millions of data, if I have to publish and generate, right, then only it will cost me some bucks. But for these things, right, it won't cost me even a single penny, because I'm not even equivalent to that data which I'm talking about right now. It's not even hundreds, like it's just a sample one. But of course, I will cover those sessions as well, like how when I will generate those kind of massive amount of data using the function apps, publishing events, and the IoT Hub solution which I will be deploying. So this is just a sample one. Now I will go to the Digital Twin Explorer. So now this is a service which has been created in Azure, and this is the endpoints and access controls. This is the service. Endpoints is something. Now when I cover the advanced things scenarios, like how the actual implementation happens, I will tell you. So the events, there is an IoT Hub. IoT Hub, this is a device fitted like for example, this is a room. A thermometer is put in that will measure the temperature of this room, and will there is a sensor device which is connected to this room, which is a thermometer, and those statistical analysis will be sent to sent to a function app in the advanced use cases. That function app or event grid I will try to register here in the endpoint. And so that that function or the service bus will try to publish the events to this digital twin, and then afterwards we can analyze the data, which is for example the example which I am trying to cover here is this is the floor, and this is the room inside this ground floor, and now there is a thermometer there in this room which is measuring the temperature and humidity of this room. So there is a sensor, it's acting as an IoT device, the thermometer. Now this data is being analyzed using the virtual representation that I will show through a graph which is called the digital twin graph. So the portal which I have opened, I just try to show you this endpoint because this is important, because the data which is generated out of this digital, this will go to output to the other function app, and we'll see the advanced use cases. But this is the endpoints which we will cover to, and then the event routes, custom event routes we can create. This is again then we define our custom routes where we creating endpoints and the event routes that they will publish the events which are which are generating terabytes of informations. And then now I think it's ready. So let me just go to it. So this is a simple representation of just giving the brief description of the so we have digital twin APIs as well. As I said, this is the PaaS offering of Azure. So we have digital twin APIs as well. The reason why I this is all things are covered. There are libraries as well. When I go to advanced ones, there are libraries and the things which are specific to digital APIs which we need to code in C sharp. It best fits with the C sharp solution. The advanced use cases where we publish the events using the libraries for the digital twins and the event hubs. We do some coding there. Also I have just cloned it using a GitHub, and I will also show the the URL now itself how I've been trying to cover that one. So that has been used. The original where we are going to show this topic was to show through a C sharp code, but as of now, I'm not equipped with the logistics with my own, that's what challenge is, and getting that at my end. So probably, yeah, simple models which I've created. You just go through this one. So video illustration of this Explorer is also available, and sample quick test scenario. You can use this one as well. But for my this thing, right, I have these are the models which I've downloaded, which is the floor and the room example which I have been showing. This now I will go through the JSON files of it. Like try to explain you the properties. What is I was just showing in one of the slide the components, the elements of the model, how we design the model, the property, telemetry, relationship component. These are the 4 components which are will be used while designing the digital twin interface. As I said, this is a sample. For example, there is a room. So room JSON file, like this is the model which we will develop now. Which so this is the simple DT. So DTMI is nothing but the DTML extension which I was referring to earlier. So this is the extension which will be used. An example is the room. This is the room one, and the property. Now comes the important part. The property and the telemetry, which will be huge amount of will be generated. So there will be telemetry and there will be property as well. So we need to distinguish what is the difference between the property and the telemetry. While the telemetry represents the statistics of the for example the temperature of this room or the humidity of this room. So it will maintain the temperature, like what is the temperature, like it's for example 25 degree 25 unit is the room temperature. So that will come under the statistics, or you can also say the telemetry. Telemetry means these are the actual and humidity, the figure which is will given, and the parameters. So that will be the statistics. Now property comes temperature. Now temperature will be measured in the double or int those data types. So that is called the property, where you define actually those things like humidity again will be measured in the double int or any data type which is there, and then comes the temperature will be a double this is the schema type or the data type which will be defining. And then comes the just referring to the slide which so yeah, then comes the this is the important part of where property, telemetry, and the relationship. Now relationship, so this is the very important one. We need to define the relationship, like this is the floor. Now the room is contained in a floor, and this room is having the thermostat device which is attached to this room, which will measure the temperature and humidity of this room. So this relationship has to be defined, like how this room is connected to the floor and how this room is again has the thermometer. So this relationship between the room and the floor is being defined using the relationship parameter, and that's what I have just it's let you represent how a digital solution can be involved with other digital solution, like floor contains the room, and this is just a simple example, but in machinery examples it could be a factory is there, and in a factory machineries are there. So how machineries are connected to the factory. So this relationship will be defined using the relationship parameter. So these are the elements which are defining the relationship, and then publishing the data using the service bus or the event hubs. And then comes the components like that are needed to develop your model. For example, you might have the in a thermometer example, you have component. What are the components inside a thermometer? For example, the mercury, which is responsible for measuring the temperature of this room. The components which are necessary, like thermometer in our case, and the IoT device could be in the case of a sensor, and there could be what we say Raspberry Pi. When you define in a larger level. So those are the components which are necessary to define or design a digital twin model. So those are the components. What all components are required to design the solution for this digital twin model. So this is just and I think this is now this is I just try to cover it with all these the properties, and DTMI is just the extensions which I have been using, and then comes the floor where we are now this room is under a floor. So now floor is a larger entity, like where we define the relationship, like because the room is contained in this room is contained in this entire floor. So this relationship will be defined in the floor JSON file. So this is like relationship means contains. Now this room is contained within this floor. So this relationship will be defined here, and then this properties, and this is all which has been defined in the floor example. Now this
so will room be a component, or is room the model?
Room will be a model in this case.
And then components in that room will be
thermometer device, which is also the sensor device. Yeah, so that's the component. So room is the model which we will be defining here, and yeah.
This is the floor definition.
This is the definition of floors.
So
Yeah.
where it is telling that it will contain a room, or in the room we have to say its parent is floor.
Yeah, in the room, relationship, if you see the parameter contains, right, in the contain the properties like ownership, user. So this, it's not defined here, but just hold on, let me check.
I think this is the relationship, and if you go to room, then you will get the...
That's what I think. In the room definition you have to tell its parent is floor.
Exactly, somewhere we have to, because here you see the property and the telemetry.
Where does it define?
But I know, though this will be, so the relationship part, right, how this is connected, this will be defined in a separate Excel file. I will show you that Excel file. This is not designed in this way, but this is like just to show. Now this is the relationship file, like how the relationship which you was asking, right, this is defined in this sample Excel file, which was, I was just coming to it. So this is not designed in this way. This is just to explain you the concept of digital twin. Then because of that I can move to the advanced scenario. So this is where you were, the question which you were asking. So this is where the relationship is defined. So room 1 is contained, derived from floor 1. So, and room 0 is derived from floor 0. Whereas the relationship, now this is the data which I was talking about. The thermometer, this is act as an IoT device. So for floor 1 and the room 1, this is the custom value, the static value which in this demonstration I have already put in. Like humidity as 60, temperature as 80. And this is the data which is being generated. So that relationship will be defined using the Excel. So I will show how to upload these things. So this is just a sample one, and I have just downloaded all these three things.
One question.
Yeah.
So this data you have taken static, but it's not static, right? It will keep on changing.
It will keep on changing.
So how you will pass?
No, but this I will show you. I can change at the time of representing in the when I will represent like graphs. I have not shown the graphs as of now. So there I can edit these values. This is the Excel file which is static.
In reality, the edit will happen on the basis of IoT device, right?
Ah,
Whatever
in
device you
reality,
pass.
it will happen.
So that you will be recording in the form of graphs, and then that graph will act as an input
Input.
to your whatever functionality you want, your code.
Correct.
In reality.
Yeah, this data will keep on changing.
Exactly.
This
And-
is just to show the demonstration. Yeah.
And how you like on the basis of time you are changing, you will be making the graph like the temperature will keep on changing.
Yeah,
So
on
after
the
some
basis of-
time,
Yeah.
you are using, or once the temperature will change, then you will record.
Correct. Actually, we use time series data. When it comes to IoT, right, we use time series data. So, according to the time, it will keep on changing. The temperature of the factory or this room will keep on changing. And
So on the change event, you will record the data, or on the basis of like after that record the data.
it will generate that value, that second question which you have, that is the actual thing. Every 5 minutes, it will record the data. So that's the, that's where we define the, the intervals. Every
That
5
comes in
minutes.
the telemetry.
That comes in the telemetry actually. But yeah, I didn't told you about this thing, that you cached it very well, so I think yeah, you
Because I
deserve
have
this
worked
one.
with so much.
So this is like because in the advanced scenario, I didn't got this concept earlier. When I was, I was doing this for my learning purpose, how it is generating data. So every, not even 5 minutes, actually it was every 2-3 minutes.
Actually, we can decide whether we want to do it on
Yeah, I
time
think,
interval,
yeah, we can
or
decide
we
that
want to
one.
do it on the change.
Yeah, we can decide that one. That is a value which we can define like after how many minutes it should refresh and see it publish the data. So that's what, yeah. So this is like I have just uploaded this one. I think I can delete this one as well so that I can show from the scratch. So how does this happen? So let me delete all the models and then probably double click. That is
Upload in the sense like it will go to Azure Digital Twins and then it will, just like app service, it will work, or like how it is?
Which one? Upload means this is the, so for example in the real world scenario, right, this won't happen. Like models is something, yes, of course you can automate uploading here. Means there's a JSON file which we need to define, and the models would be created. You have to define those models, you have to create those models, like just as you define the YAML files, right, like for the build pipelines, and you configure those. You can commit in the pipeline, and then you can automate this one. This is the manual thing which I am just showing. You have to define, like just you are designing the YAML pipelines, you can define the models using in the JSON file, and what parameters do you need. This is just a sample one, and then you define the relationship which are defined using the Excel. Then once you upload all this data here, then only you will start generating the, get the virtual representation of the things which will be represented here soon. So yes, of course you have to upload these things, and this can be automated as well. So when it comes to models, now this is twins and this is the model. So model is like we'll upload the models which we have just defined, the floor and the room example. So just hold on. So I have to just save this one. So now see, if you see now, I think still if you see, let's see what the data it's been generated. I think relationship graph I've already uploaded. That's why. So this is how you build upload a relationship graph. So this. So if I delete this one, right, the relationship graph, if I delete this entire digital twin instance, then this relationship also will get deleted. So this this relationship contains relationship came from this Excel relationship Excel file which I've just defined, and the properties which you was referring to, right, the editing part we can do in the here itself, like when you see here metadata, and this is the temperature, and this is the temperature 70 custom, and this is the humidity which has been defined for room 0. This is all defined here, like For room 0, this is the init data which I can change at runtime also. There was some question regarding this, so I can change in the runtime and then try to query. This is the digital twin graph query. It's a bit worse like a SQL query itself. Like for good amount of data which you are getting from the machineries, from anything, right, on the robots or anything. This queries, SQL queries, these are SQL queries which we can use. Not the joins thing. I think I have not worked on joins, but I think simple SQL select queries with the clauses, it will work. So these are called digital twin graph queries. These are called. So it's pretty much like SQL queries. And there is when you define this is like this, and this is comes the models, different kind of models, the representation.
Basically,
This
it is using SQL or some other kind of a database. I didn't get, like, we are writing a query. So basically, like, is it using SQL or like file system? Use it, like, how exactly it's using it?
Okay, think in this way. Till now you are playing with data. Your code is using your database, right?
Yeah,
Here, instead of using your database, you have device, IoT device.
I got it. The
Okay,
data.
so that data directly will go to your code. So no manual intervention, no DB need to create. Directly that data will be fed to your code and you
Somewhere
will
we have to store it in a file system or somewhere, like, how it will fetch it?
this will be stored in a end-to-end solution in a storage account, right? We'll provision a storage account, and storage account, the scenarios which I was referring to, right? That function app will write those data to the storage account, and from there it will be
So the
published.
service acts like an input to my function app and then it will store it.
Correct. Yeah, that's a correct use case. So that's where comes the advanced things, and but yeah, that's a good one. Like it should store somewhere. So that's a for
you can use anything actually.
yeah. So that's a good insight, because yeah, it makes logical to store this data. There's some something needs to be stored somewhere. So that becomes your storage account you can use, or you can use a data lake also to store those events. So this will all be stored in the storage accounts. So and then the scenarios which you mentioned, then it will be published to the function app.
Storage trigger, you can write it and you can.
Correct. And then you need to connect those things with the endpoint, which I was just showing. Yeah. So to cover those scenarios. So now I just query with some sample. I will just change the temperature to 100, and then query using yeah.
The use case is still not very clear about this.
Means?
If I can create my own app, I can create my own relationship, I can create my own model,
Yeah.
I can get the data from IoT. So what is the specific purpose of digital twin? And I can pass that data onto the Azure function also.
It's
Yeah.
kind of service actually, just like your app service.
Yeah, it's a service. It's a PaaS offering. So it's a PaaS offering where it's a the real use cases comes like when you have petabytes of information, the data which is coming from the machineries, from the robots or the turbines, like the oil leakage problem can be solved.
No, that is fine.
No.
I can get those data via IoT device, maybe into Event Hub or something, and I can read those data somewhere and put it on somewhere, and I can expose that data. But what is the real use of digital twin?
Use case of Azure Digital Twin, where it comes in.
Is it kind of like I have a web API or some other applications? So I use the app service and then I use it. So in the same way, like cloud which provides me Azure Digital Twin, where I use it for IoT devices or some other things. I don't know the reason. Like, is it a kind of
Yeah,
way
Digital
or?
Twin.
It will what I can say, it will simplify the things. This is just kind of sample scenario which I have just shown, very basic to basic one. So this will the actual problem in the happening in at the center where we are not present, and we want to analyze. This is just a textual linear representation, I would say. If you go in and now check in the YouTube's the videos which are kept, this is not even there. This is they have actually virtually represented that turbine in this spatial model, the digital twin, and then there, the shaft which is rotating, right, it is generating the events. So this is not even there, that this is like to, just to explain.
So it will be two ways now. So if we want to make some events more specific, like temperature will increase up more than 100, then we can make some events, right?
We can, this is the custom runtime events which I can, so in this way, yeah, so the events which I am the parameters which I am changing right now, right, so I can analyze, predict what will happen if I increase the temperature of this machinery, or if the factory temperature keeps on changing. So what will we can predict the change. This is, as I said, it's just a linear representation. This won't give any predictive maintenance. Like,
Our temperature will increase more than 40, then we want to return some event and want to do some
yeah, the
events.
trigger we have to create. Yeah. So that will happen when we link what you say. For that we will have these things, right? Event hubs.
See, double two ways now. One will get the data and one will return some triggers.
What is exactly the twin?
So yeah, so that's why I think we have these event hubs and service bus to so that we are aware of this, the triggers and events which we are saying, right? This is not part of digital twins. So that's where we have the endpoints which I just showing. We have to connect those things in the digital twins. This is acting like a
Only one way.
it is acting like a one. No, it's a what you say when you so I have worked in data engineering as well. So it's acting like a data bricks or a data factory. It is a processing part. It is not even to events. You have to create it events to trigger those things. This is only beautifying the statistics. That's it. It's not very
In local
much.
environment, like I want to do it in local. I don't want in Azure Digital Twin to use it anyway. Like we can do it in local, like the way Jason you're writing it down. That I want to test it and other kind of a simulation in local only. And later I want to go for Azure Digital Twin. Is there any way?
Yeah, that's also a good one. But for this one, I think I can correlate with my own experience now. So for example, in ABB we are using Robot Studio. So Robot Studio is inside using digital twin. So it's a what I can say, so the device and controllers are still kept there in our labs, but the Robot Studio will a virtual controller will be there in your PC, which can test the functionality of the robots, controllers, and the T pendant.
Just
So
like Android Studio, Xamarin Studio.
that you have to install those. So with the technology like in our ABB we have Robot Studio, which comes up with this digital twin is already inbuilt in that. That's all on-premise. They are not using any Azure cloud technology. So that will represent a virtual representation, as if the controller is there inside. You are using it and actually controlling two robots. So that is, I saw this, what you said, right? I saw this when this, hybrid started happening. I saw this in one of the labs of robots, like how they are using digital twins inside. Like if I don't want to use this, you can skip this. Then you too need to have that, software to simulate the environment. That is simulation. Simulation software is available. Like for example, in ABB we have Robot Studio to analyze because in the COVID times we were not there in the labs, we were not touching controllers and all those things. Then comes the these software that can simulate this environment. Simulation softwares were there. This is how we work here in ABB. But I think in IBM, Siemens also they might be using the technology behind all these things is digital twins only. So now which I was just trying to cover the concept of it. Like what is it, like the virtual representation. So they are using the digital twin inside. But the cloud offering even I would say not even ABB, not in all industries they are using their custom digital twin solution.
So
That
field devices, all the
field devices they are using. With the scenario which you said, right, don't want to use this, I can use in a local PC and test it, how my controller is and robot are behaving. So you can use the custom software written. Either you have to write if it's not there.
protocol communication, Profibus, Fieldbus, the different Fieldbus, that also will come into picture here, or
Which feedbacks, what?
let's say devices, we have field devices,
Yeah,
different field devices, temperature measuring devices,
yeah,
or pressure measuring devices.
yeah.
So usually we have a devices, so we have a protocol like Profibus, Fieldbus, hard protocol kind of a thing in ABB. So they internally uses these protocols, and then once again the XML kind of format, and they will give an input to these things.
Yeah, so they will. So that will actually give through the simulation software also. They can give the input to the real devices. So they can test the components because see our here in this ABB the simulation devices act as like you are physically present in front of the robots or the controllers who are controlling the robots. So so the commands are going actually, but it is here in our organization. It is not necessary every time to to move the robots here and there. So it's just the concept of teach pendant in the controllers. The controllers are connected to the robots. So these are three components which we are using in the robotics department. So teach pendant is something you teach the the movement which you track of the robots, right? So those teach pendant and controllers are virtually represented in our system. Robots sometimes it's not there, and sometimes for robots one service engineer has to be there in the lab because it's kind of dangerous thing like to operate without supervision. But I think things will evolve in this industry 4.0.
In VS Code, it is the extension.
No, actually, devices understand only XML type. So that XML once again in a kind of a JSON way you have to get it, because device always communicates in ABB or in automation industry. Always your data will be in XML format.
I think you can search the extension in the VS Code.
So yeah, I think so. This is the basic of the basic things which I want to discuss. But yes, I think I have attached the slides. I can mail, and then this is just the representation of what I have done. So this is the pricing part. So for these million messages, this is the cost, which will happen in East to West 2 for the cloud offerings. So this you can see per million message, like this many events I have to generate to get into these parameters. So that's it, I think. And then we have the links, which I've just used to prepare for this demonstration. I think that's it.
One question. You uploaded that model file, right? That floor.
Yeah, it's there in these links itself. Just downloaded. Yeah, the sample one is available in docs.microsoft.com.
And even in Azure, it is in preview mode. This Azure Digital.
No, it's not in preview. It was in preview in 2018.
Okay, now it's
2020 December during times of COVID. December 2020 GA now. We have general availability service now. It's being used now.
Do you have any demo like how it will, how that model after running that, how we can check like sample one?
Models like this is because I already uploaded. I just wanted to show because but I'm running. I think I need to buy one more from Anand. I will try to cover in the advanced scenarios because even I didn't like this basic one. So this will come when I just want to show the custom query where you can design the query also t.temperature where yes, you can define those things. You can and query this temperature greater than let's say greater than or greater than 90 and just run the query and see what happens. Okay, I think whether the TEM 16. So if you see, so for like for how many rooms this temperature is greater than 60. So if you see, the temperature for this room was 80, and for this room it was I think I added it to 70. So let me make it to greater than 70 and see what parameters will come. So I think only room 1 scheme. So this is where you do the querying part, and this is just a linear representation. The models you can select from, these are the models. I'm also still not sure what all these does. I'm still learning on these ones, but these are different, the ways of representing the models. And yeah, so this is the the representation scenarios, and how in and out we'll see when I will cover the advanced scenarios, how this will come into the picture. In this demonstration it's difficult to explain about all these, but yeah, I'm planning to cover the advanced use cases as well, as I'm also working with the engineering teams in my company to to have these cloud offerings as a first step to move to the cloud for our IoT solution. So this is the start, because as things are evolving there, so I'm also planning to speak up in the events as I learn myself and do the things. Then I will cover those scenarios as well. Yeah.
How is better than Power BI?
Power BI, it's just analytics tools, and sometimes linking here also, this we can, the output of this digital twin, we can put it in the Power BI, but the Power BI is like more on the, I think, the linear statistics, graphs, pretty much same things which we can also
Because
observe.
I worked in IoT projects, we used to
Use Power BI.
Power BI.
Even I am using both Power BI. I am using still Power BI. So yeah, that's a good one, because measurements of the data, the reports which we are to the business which we are sending is to Power BI only. But this is like we can know the things which were asked by him, like the simulation softwares, right, which has helped us, like when we were not present in the labs and we want to analyze some data through the, for example, ABB Robot Studio. So that simulation, the technology behind it is not Power BI, it's the digital twin. The simulation which happens. Simulation is not covered by Power BI. It's just the statistics.
On the basis of data.
On the basis of data only. This is data plus artificial intelligence plus simulations. So simulation is not there in Power BI. So yeah, but yeah, I can go later. Measurements we
gradually it will increase some functionality.
yeah, of course it will increase the functionality, but I think Power BI has its still own place. Power BI can't be replaced with the offerings which Power BI has to offer, because the measurement of the robots we are still tracking, the business we are still generating the reports and sending them using Power BI dashboards. So yeah, but yeah, this is a separate thing. Simulation is not there. That's the main difference, I think.